All right, guys, so we just looked at page 77 here, talked about absolute values. I want to do some more solving problems with you on 76. So if we take a little look, let's say we have absolute value of x minus 1 equals 2. We said that to solve an equation with absolute value bars, we needed to get the bars alone. Now these bars are already alone because there is nothing outside of them. So right away, I can make my two equations. And the reason that we need two is because the absolute value, whatever was in here, it could have been 2, because like absolute value of 2 is 2. Or it could have been -2 because the absolute value of -2 is also 2. So we set what's inside the bars equal to 2 because it could be that, or it could have been -2. So we get our two equations, always two equations because we're always going to have two answers. And so then we just solve each one. So x equals 3 or x equals -1. Now, in our last video, something happened where we had no solution. So we want to get in the habit of always checking our answers. So the way you check your answer is you take your original equation, absolute value of x minus 1 equals 2, and we're going to put our answer in one at a time. So let's take the 3 first. If I do 3 minus 1 and then take the absolute value, is that 2? And it sure is. So now I know that 3 works, but I also have to check the -1. So if I put -1 in place of x, -1 minus 1 is -2. And the absolute value of -2 is 2, and 2 does equal 2, so this one checks out as well. So I know that they are both answers. Okay, now we can do that with any sort of problem. It doesn't have to just be an absolute value problem. Let's try another. 5, absolute value, x plus 1 plus 4 equals 14. Okay, so again, we want to get our absolute value bars all alone. And so looking at the side where the bars are, there is a number being added that I need to get out of there. Also, the 5, because it's smashed right up next to it, it's being multiplied, and I need to get that out of there. But when we're solving, we always get rid of addition and subtraction first. So we'll subtract that 4 and write down what we have left. Then, again, because that 5 is being smashed, I can't actually multiply it in. I know they're kind of like parentheses, but you cannot distribute into the absolute value bars. So we got to divide it away. And so we'll have the bars alone finally equals 2. And so once my bars are alone, I make my two equations. Okay, so we get x plus 1 equals 2 or x plus 1 equals -2. We always keep the inside the same, change the outside number. Okay. All righty, so subtract 1 and we get that x is 1 or x is -3. So you can see like something else that we talked about too is the numbers don't have to be opposite of each other. They could be completely different numbers. Like over here when I solved it was 4 and -4, but they're not always going to be the same number but different signs. So, all right, let's check our answer. Check, check. So if we go back to our original equation, then we want to plug in our 1. So we'd have 5, 1 plus 1 in the bars, plus 4. And now it's like a question, is that 14? Let's simplify. So we got to do what's in the bars first, and 1 plus 1 is 2. And then the absolute value of 2 is 2. Smashed up against a 5 makes it 10, plus 4 is for sure 14, so that all works out. Then we got to try our -3s. So we got 5 and then -3 plus 1 plus 4. Does that equal 14? Oh my God, why didn't I just write this on a different line? Like I can't fit that in there. What was I thinking? Ugh. So inside the bar is -3 plus 1 is -2. Then I got plus 4. Is that 14? I don't know. Well, the absolute value of -2 is 2. Smashed up against a 5 is 10, and 10 plus 4 is 14, so it all works out again. So they are, in fact, both answers. So let's try one more. Lucky number 3. Let's do 3, absolute value, 2x plus 9 equals -3. Okay, so if I put my sides in, over here with the bars, there is something outside that I need to get rid of. And that 3 is smashed up against the bars, which means like multiply, so we'll divide it away. So we'll have absolute value 2x plus 9 equals -1. Then we make our 2 equations because now the bars are alone, so we'll have 2x plus 9 equals -1, and 2x plus 9 equals +1, because we have to always change the outside number. Now you might be thinking like, Missouri, what are you doing? And if you are, good for you. But if not, let's keep going. So I'll subtract my 9, and we'll have 2x equals -10. We'll divide the 2, so x is -5. And then over here, subtract the 9, we'll have 2x equals -8. Divide the 2, and x is -4. So we potentially have our 2 answers. Let's go check them. Check. Okay, so going back to my original equation, we had 3 absolute value, 2x plus 9 equals -3. And so if I first take -5 and plug it in, now it's a question, will that equal -3? So if we do what's inside the bars first, we'll have 2 times -5, which is -10, plus 9, which is -1. Now the absolute value of -1 is 1, times 3 is 3, which is not -3. So if you were thinking before, like, Missouri, what are you doing? That was great, because right at the top, like right at the very beginning of this equation, I already knew something was sus. Actually, to be fair, once I moved the 3 over and got the bars alone, I knew something was sus. Absolute value bars can never equal a negative number. So the moment you see something like this, you really don't need to go do the rest of those things. It's automatically going to be no solution. Now, the reason I wanted to go through and do it all, though, is like you can still use math and find answers. But when I plug those answers back in, I get a false statement. So they're not for real answers. They're for fake answers. They're fake friends. We don't believe them. We don't like them. Okay. So similarly, that happened over here in our previous notes. And I didn't even continue because I knew right off the top that bars cannot equal negative numbers. That just automatically tells me there is no solution. Alrighty, hopefully we're feeling okay about solving, and next time we'll talk about solving but with inequalities rather than equalities.